All right, chemists. So today in class, well, previous to this, we've been learning about acids and bases. And we learned what made an acid, what made a base. In general, things that start with H equal acid, and ionic compounds with OH equals bases. We also have, this is A, and then we have that special one, which is NH3, that is a base as well. So what we find is that, and you don't need to write this whole chart down, but you should notice some patterns that when your concentration of H, this is high and this is low, more H plus makes a lower pH. So the formula is this: pH equals the negative log of your concentration of H plus. Now, log is just a button. I mean, it's not just what it is, but for what you guys need to know, this is a button on your calculator. And I'll show you in class how to do that. But I'm less concerned about you understanding the math and more concerned with you understanding that with H plus concentration, as it goes up, your pH goes down. As your OH concentration goes up, your pH goes up. So they're inversely proportional. So what we're going to do is write down some patterns from this. The pH scale is a logarithmic scale that describes the concentration of H plus ions in solution. So here's what I want you to do. As H plus goes up, pH goes down. So what this means is low pH equals highly acidic. So the lower the pH, the more acidic a solution is. So then when pH equals 7, the concentration of H plus equals the concentration of OH minus. What this means is you have a neutral solution. So in theory, this is pure water. Neutral solution of pure water. Now, the stuff we get from the tap we know is not pure water. There's stuff dissolved in it. So the pH of our tap water is not quite 7. But the deionized water that we get, it should be right around 7. And H plus and OH minus are inversely proportional. As one goes up, the other goes down. So if you have a high concentration of OH minus, that means you have a low concentration of H plus. There's actually a formula for this. H plus times OH minus equals 1 times 10 to the minus 14th. So if you have one concentration, like say I have the concentration here, I can use this equation to find the concentration of OH minus. And the last one I put on the previous page, but pH equals negative log of H plus. And really, you can approximate that by looking at the exponent. So you can approximate pH by the exponent. So, for example, 1 times 10 to the minus 3, if that's my H plus concentration, then that does not look like a 3. Then the pH is equal to 3. So you can approximate it just by looking at the exponent. So here, again, I gave you this already. You don't need to write this in. But H plus times OH minus is 1 times 10 to the minus 14th. And as H plus goes up, just write this in again, OH minus goes down. And vice versa. Those are the key points. All right, last slide. I believe. Yeah, last major slide. So, in any solution, the product, I know I'm repeating myself here, but these are important points, of H plus times, and this is concentration, those brackets mean concentration, times concentration of OH minus. Wow, that looks really awful. I'm sorry, guys. Yeah, let's just cross that out. Not much better. But is constant. So as one goes up, the other goes down. Now, water, this is true in water. Water dissociates very, very slightly. No, slightly. Remember, dissociate means to break apart. Slightly into H plus and OH minus. But the cool thing about water is for every H2O, you get one H plus and one OH minus. So if you just have water in your solution, you have equal amounts of H plus, equal amounts of OH minus, which means your concentration, your pH is neutral. And I do want you to draw this in. Now, if I do something like add a base, well, if I add base and my OH minus goes up, well, then my H plus has to go down. Or if I add H plus, my OH minus has to go down because the product of those concentrations are equal. Okay, summary. How is pH related to the acid or base concentration of a solution? It's a scale that describes the concentration of hydrogen ions. pH is log of H plus. H plus concentration is related to OH minus, so you have this product of the two equals 10 to the minus 14th. And as one goes up, the other goes down. pH of pure water, pure in there, is 7. In water, the H plus concentration is equal to OH minus, thus water is neutral.